Okay, I am in the 1.3 notes, picking up where we left off. We've been talking about sampling. We did our Beyonce activity with the simple random sample versus convenience sample. All right, we're gonna learn three new ways to random sample that are pretty common, and it kind of depends on what data you're trying to collect to determine which method is most suitable. But these are all examples of other ways we can random sample other than just doing an SRS by just doing a random number generator. Okay. So these are pretty three big, I'd say pretty big vocab words for today. First one, a stratified sample. So to use this method, you divide your population into groups, and we call the groups strata. That's why this is called stratified sample. The groups called strata. And you take a proportionate number from each strata, or each group. Okay. So how you choose how to group them, or the strata. I could jot this down too. You want to group them based on characteristics that may affect their responses. Okay, and then I put a little example in here for you. And again, this is an example of a random sampling method. Okay, so I kind of copy and pasted this example from this textbook because I kind of liked how it compared these three methods we're going to talk about today. So let's say we want to collect a sample of the number of people who live in West Ridge County households. Okay, so we're kind of trying to find the population of people who live in these West Ridge County households. So if we wanted to take a stratified sample, what we could do is we could divide the households into some common characteristics that they all have that might affect their response to the survey. So in this case, how they decided to divide them was by their incomes, their socioeconomic levels. Okay, so they grouped one of low income, middle income, high income. So there's your strata. And they group them based on these characteristics of their income, because that might affect how many people live there, possibly. Okay. So an important thing about the stratified sample is we take random, we select random people out of those categories then. Okay. So the proportionate piece of this is I might only select 2 from the low income, maybe 3 from the middle income, and 2 in the high income because there's more middle income. So I'm going to select from that group where there's more represented of my whole population. Okay, so here it says that's the whole proportionate part. Here it says, for instance, if only 40% of the people in West Ridge County households belong to the low income, then we're only going to select 40% of our sample from this group. Okay, that's a stratified sample. So you divide them into characteristics, and then you randomly select from each strata, each group, with proportion to how many people in this case are part of that category. Okay, so basically stratified, group them with some similar characteristics, and select random amounts out of each. Now, how you decide which ones, you can do a random number generator. There's other like ways to decide which exactly of those. Usually, like a random number generator is the most common, but that's a stratified sample. Next one is a cluster, and they feel very similar, but they are different. So a cluster is we're still going to divide the population into groups, but the difference between a cluster and a group, we'll talk about that. So divide population into clusters. These ones are usually, you kind of just cluster them based on convenience. So in this, they cluster them by their zip codes of this group lives really close together in these neighborhoods, zone 1. We're going to cluster together these in zone 3, zone 4, and zone 2. So here you don't have, you can still like cluster them according to like a characteristic if you wanted to. But usually for clusters, you will kind of more like just conveniently group people. Here's the difference though. Instead of randomly selecting people out of each cluster, we randomly select a cluster. Okay? So then we'll randomly select maybe 1, maybe 2, some of the clusters, and everybody in that cluster is sampled. So I write that down. All members of the selected cluster are in the sample. Okay. So going back to like that same example, if you want to survey the number of people, not survey, I should say survey. If we want to know the number of people who live in Westridge County households, how we would do it using a cluster sample is we're going to still divide the house into groups. This time they decided to do it according to zip codes. But here's how it's different. If I did it in like these 4 zones, let's say, okay, obviously we're not going to sample every single person. We're just going to choose one of the zones and we're going to survey every single person in that zone. Okay, so with a stratified, we select random amounts out of each strata. In a cluster sample, we randomly select a cluster, and then that's our sampling group. Everyone in that cluster. That's a big difference. In using a cluster sample, care must be taken to ensure that all clusters have similar characteristics. So here's where it's a little different. Though in strata, we kind of group them according to their characteristics. Here, we don't really want to do that. Like I said, you could, but we don't want to because if I clustered this with all the low-income people are in zone 1, then I'm just surveying the low-income people. So here, when we cluster, we kind of want like a mix of all the different characteristics, and then we randomly pick a group and survey all of them. Because again, we're trying to be like as accurate as possible. All right, the last one I'm going to introduce you to, and I found a YouTube video that I feel is a really good visual for these 3 that we'll watch after this. But this is our third one, is a systematic sample. This one's a little bit different. This one, you randomly select a starting point. So maybe I'm going to start at house number 86. And then you just do like a pattern almost. Every, I'm going to say nth number. And when I mean nth number, it could be like every second house, every third house, every 5th house. It could be any number whatever your system is, it's a systematic sample, and piece of data from a listing of the population. So going back to our West Ridge County household example, I could just decide a random starting number, and maybe I could select like every 100th house is what this one says. So let's say I randomly chose to start at house number 86. To decide who's going to be my sample, I'm just going to do every 100th household, and there's my sample. Okay, so some sort of pattern. That's a systematic sample. Okay, I'm going to show you guys this video. Like I said, I feel like this is a really good visual. I'm going to pop it on the wrong screen. Of these three different types. It's just a like 5-minute video. And this also throws in simple and convenient, which we talked about.
Sampling: simple, convenience, systematic, cluster, and stratified. To find things out about a population of interest, it is common practice to take a sample. A sample is a selection of objects or observations taken from the population of interest. For example, a population might be all apples in an orchard at a given time. We wish to know how big the apples are. We can't measure all of them, so we take a sample of some of them and measure them. The method chosen for taking the sample depends on the nature of the population and the resources available in terms of time and money. The ideal is for each object in the population to be equally likely to be chosen as part of the sample. This is called an unbiased sample. It is also desirable for the sample to be representative of the population. If the population of apples were 2/3 red and 1/3 green, the sample should be similarly split. Note that no matter what we do, there will always be sampling error or variation due to sampling, as we are looking at a part of the population, not the whole population. The video on variation covers these concepts more thoroughly. This video presents 5 methods of sampling: simple random sampling, convenient sampling, systematic sampling, cluster sampling, and stratified sampling. For each method, we will outline the process and the advantages and disadvantages. Simple random sample. Simple random sampling is theoretically the ideal method of sampling. You list each member of the population and use random numbers to decide which objects are in the sample. Each object is equally likely to be selected. This produces an unbiased sample, which we hope is representative. However, it can be difficult and expensive to take a simple random sample when dealing with people. Simple random sampling is more practical when the population is geographically concentrated and when a good sampling frame exists. A sampling frame is a list of all the people or objects in the population of interest. Simple random sampling can be more easily implemented for natural and manufacturing populations. Convenient sample. Convenient sampling is just that, convenient. You ask people nearby or people who walk past at a shopping mall, or you take the next 20 objects off the production line. You do what is easy or convenient. Convenient samples are often biased in some way, but for a quick and cheap poll, it may not really matter. Convenient samples can also have self-selection bias when people choose to participate because they have an interest in the issue in question. Systematic sampling. With systematic sampling, you choose a starting point at random and then systematically take objects at a certain number apart. For example, if there are 1,000 in the population and you want a sample of 50, you would take every 20th object. Systematic samples are easier to administer than simple random samples and are usually a good approximation of a random sample. However, if there is a pattern in the population, certain types of objects could be chosen more or less often than others. Cluster sampling. In cluster sampling, the population is divided into clusters which are then chosen at random. For example, departments of a business can be clusters, or suburbs within a city. Within each cluster, all of the objects are included in the sample. Cluster sampling can be more convenient and practical than simple random sampling. However, if the clusters are different from each other with regard to the elements we are measuring, it can lead to bias or non-representativeness. Stratified sampling. Stratified sampling seems like cluster sampling, but the strata or groups are chosen specifically to represent different characteristics within the population, such as ethnicity, location, age, or occupation. Within each group, a random sample is taken, sometimes in proportion to the size of the group. Stratified sampling can lead to a very good random representative sample. However, it can be complex to administer, and a sampling frame with considerable information about the population is required. There are other sampling methods. The 5 explained here give an idea of the advantages and disadvantages of various methods. You should attempt to use the sampling method that produces the best result for the resources you have available. If your sample has known bias, this should be taken into account in analysis and reporting.
My job is to make college easier because students have a lot of fun.
Okay. I feel like that's a good like visual of each different sample. I don't know if it's in Okay, any questions? Can it make sense? On the differences?
Yes.
Okay, let's try an example problem. You are doing a study to determine the opinions of students at your school regarding stem cell research. Identify the sampling technique you are using when you select the samples listed. Discuss potential sources of bias, if there's any. We talked about bias. So, then we talked about sampling bias too. It's like on the very first part of your notes, but you know, like convenience sampling, that's like obviously like a lot of bias. And with the random samples, the goal is to like reduce bias. Okay, number 1 here. You divide the student population with respects to their majors. Oh, we're in college, I guess. With respect to their majors, and then you randomly select and question some students in each major. Stratified. Good job. How'd you know that? Good job. Perfect. Stratified. We group them together according to a similar characteristic. That's our strata. And then since we randomly selected from each strata, that's our strata sample. So since this is a random sample, there'd be low bias. Students are divided into strata, which Austin said that perfectly. That was their majors. And a sample is selected from each major. Okay. We can put low bias. Low bias because it's a random sample. All right, number 2 says, you assign each student a number and generate random numbers. You then question each student whose number is randomly selected. What do you think for that one? Okay. Nope. Systematic would be if I did the first student and then every 10th student, you're part of my sample. You're part of my sample. It can be more than just these 3. If you're stuck on just these 3. Allison? Simple random sampling. I'm going to say SRS. SRS. Again, that like generate random numbers. That's like what we did with the Beyonce one. Generate random numbers to decide which words out of the lyrics we're selecting. So here, each sample of the same size. I don't really like how this is worded, but each sample of the same size, or you could say every person has an equal chance of being selected for your sample. You could say it that way too. Each sample of the same size, that means whatever group of numbers I choose has an equal chance of being selected. No. A cluster would be if I still randomly grouped, maybe I could like group them according to like what classroom they were in. And then I would select one classroom and survey every single person in that classroom. Like you pick one of the groups and then you survey everybody from there. You don't really randomly pick like students from each classroom. Good question. This would also be low bias because it's a random sample. All right, third case scenario. You decide just to select students who are in your biology class. Convenience, good. Yep, convenience. And that's going to be high bias because if we're talking about stem cell research, people in my biology class are probably a little bit more interested. And I'm not randomly selecting anybody. I'm just, hey, you guys are close to me. Convenience sample. Sample is taken from students who are readily available. So part of your ALEKS assignment for 1.3, part of it is reading through scenarios like this and deciding what type of sampling method is being used between these ones, between convenience, simple random sample, stratified cluster, and systematic. Okay. So for the bias, I would say high bias. And then you can also say, kind of like what I was saying, biology students may be more familiar or interested in stem cell research. So that wouldn't be a great sample on the entire population of all students at my school. Stem cell research. Okay. That's all we're going to do for notes. But I have another activity. Yes, sir. Yes. Thank you for waiting until the notes are done.